Hello everyone, I am Akshaya from Department of Geology, A.D.M. College for Women. Today I am going to discuss about the ocean floor, and main objective of this video is to give a brief knowledge about the ocean floor. For this content I am referring the Essentials of Oceanography by Trujillo and Thurman. In this video I am going to discuss about the what are the features exist in the ocean, how the ocean floor is classified. Now we are going to discuss about the ocean floor. As you guys know, the ocean is occupying more than 71% of the earth crust, and more than 50% of world's population live in the ocean area. So ocean is an important region in the geology. So ocean floor. Ocean floor can be divided into three major provinces or three major segments. The first one is the continental margin. The continental margins, which are shallow water areas near to the continents. Next, the deep ocean basin. The deep ocean basins are deep water areas farther from the land, that is after the continental margin. And third one is the mid-oceanic ridges. The mid-oceanic ridge is a feature of divergent plate boundaries, which is composed of shallower area near the middle of the ocean. In the picture, you can see the continental margin, the ocean basin and the mid-oceanic ridges. Continental margin lies near the shore. Next, the deep ocean basin where the higher depther places are located, and then finally the mid-oceanic ridges, which is located at the center of the ocean. Next, we will see about the continental margin. Continental margin is divided or classified into two. One is passive continental margin and second one is active continental margin. This classification is based on their proximity to the plate boundaries, whether it is located in intraplate feature or interplate. First one is the passive continental margin. Passive continental margin is a intraplate feature. It is embedded within the interior of lithospheric plates, that is located at the center of the tectonic plate and not in close proximity to any plate boundaries. And passive margins lack major tectonic activities like earthquakes, volcanoes and mountain buildings. Features located in the passive continental margins are continental shelf, continental slope and continental rise that extends towards the ocean basin. Second one is the active continental margin. Active continental margins are associated with the lithospheric plate boundaries and are marked by higher degree of tectonic activities like earthquakes, volcanoes and mountain building. In this active continental margin, it is also divided into two. One is the convergent active margin and second one is the transform active margin. Convergent active margins belongs to the convergent plate boundary and the transform active margins belongs to transform plate boundary. Convergent active margins are associated with the oceanic continental convergent plate boundaries. In these two oceanic plates moves towards each other. From the land to the ocean, features include an onshore arc-shaped row of active volcanoes, then a narrow shelf, a steep slope and an offshore oceanic trenches that delineates the plates. The best example for the convergent active margin is Western South America. In this place where the Nazca plate and the South American plate moves towards each other and the Nazca plate is subducted below the South American plate. Second one is transform active margin. In this transform active margin, two plates slide past each other like this, are less common and are associated with transform plate boundaries. At this location, offshore faults usually parallel the main transform plate boundary fault and creates a linear islands, banks and the deep basin closer to the shore. The best example for transform active margin is coastal California along the San Andreas fault. Next, the continental margin. The continental margin is divided into three parts. First one is the continental shelf. Second one is the continental slope and finally continental rise. Now we will see about the continental shelf. Continental shelf is a flat zone. flat zone extending from the shore beneath the ocean surface to a point at which a marked increase in the slope angle occurs and it ends at the break called shelf break. Shelf break is a location where the continental shelf ends and the continental slope starts. It is usually, the continental shelf is usually flat and relatively featureless because of marine sediments deposited but can contain coastal islands, coral reefs and raised banks. The underlying rocks of continental shelf is granitic in composition. So, geologically, the continental shelf is belong to continent, not ocean. In this picture, you can see the passive continental margin and the active continental margin. In the passive continental margin, you can see the continental shelf, then slope, then rise. After that, abyssal plains and rift valleys are there. But in the case of convergent active continental margin, after continental shelf, there was a deep valley called oceanic trenches is present. Next, the continental slope. Continental slope lies beyond the shelf break, that is beyond the continental shelf is where the deep ocean begins. Total relief of continental slope is similar to that found in mountain ranges on the continent. The break at the top of the slope may be from 1 to 5 kilometers above the deep ocean basin. Worldwide, the slope of the continental slope is averaged between 4 degrees but varies from 1 to 25 degrees. And third one is continental rise. Continental rise is just a transition zone between the continental margin and the deep ocean floor. It comprises of huge submerged and piles of debris. So, the sediments from rivers drain over the continental shelf and finally reaches the continental rise. Next, we will see about what are the features exist in the continental margin. First one is the submarine canyons. Submarine canyon is an important feature which is usually located in the active continental margin. So, the active continental margin contains a continental shelf. After that, there was a trench or a valley is present. That trench or valley is called a submarine canyons. Continental shelf exhibit submarine canyons which are narrow but deep valleys that are V-shaped in profile view and have a branches or tributaries with steep to overhanging walls. The submarine canyons resembles canyons which is formed on land that are carved by rivers and can be quite large. In submarine canyons continue to the base of the continental slope which averages of some 3,500 meters below the mean sea level. Both indirect and the direct observation of the erosive power of turbidity current has suggested that they are the responsible for the curving submarine canyons. So, turbidity current is the only source for curving the submarine canyons. Turbidity currents is nothing but it's just a underwater avalanches of muddy water mixed with rocks and the other debris. So, the sediment portion of the turbidity current that is the muddy debris comes from the seafloor material that move across the continental shelf into the head of submarine canyon and accumulate there, setting the stage for the initiation of turbidity current. In the picture, you can see the submarine canyon, how the fluvial action transport the sediment and how it is deposited in the submarine canyons. Next one is the turbidite deposit. As I already told, turbidity current carries the sediments from river and deposit in the submarine canyon. That deposit is called a turbidite deposit. And individual turbidity current deposit one graded bedding sequence. At a time, a turbidite current deposit a single turbidite deposit bed. The next turbidity current may partially erode and the previous deposit and then deposit another graded sequence on top of the previous one. After some time, a thick sequence of graded bedding deposit can develop one on top of other. These stakes of graded beddings are called turbidite deposit of which the continental rise is composed. As viewed from the above, the deposits at the mouth of submarine canyons are fan or lobate or apron in shape, and it is consequently these deposits are called deep sea fans or submarine fans. For example, in Bay of Bengal we have a Bengal fan. And second division of the ocean floor is the deep ocean basin. The deep ocean basin are those areas found below the sea, lies beyond the continental margin. As I already told, about 70% of the earth's surface is made up of ocean basin. Next, we will see about the second part of ocean floor, the deep ocean basin. The deep ocean basins are those areas found under the sea and lies beyond the continental margin. About 70% of the earth's surface is made up of ocean basin, and it can be either active ocean basin or inactive ocean basin. The ocean basin contains lots of features like abyssal plain, volcanic peaks, oceanic trenches and the Pacific ring of fire. Next, we will see the features step by step. This is the picture where the continental margin, deep ocean basin and the mid-oceanic ridges located in the Atlantic Ocean. Next, we will see about the features located in the deep ocean basin. First one is the abyssal plain. Abyssal, A means without, byssus means bottom. So, abyssal means without bottom. It is extending from the base of the continental rise into the deep ocean basin. The flat depositional surface with slopes of less than a fraction of degree that cover extensive portion of the deep ocean basins, and the abyssal plains averages between 4,500 meter and the 600 meter depth. The abyssal plains are formed by thick blanket of sediment is produced by suspension settling of fine particles like silt, clay and sand slowly drifting onto the deep ocean floor from the continental margin. The abyssal plains cover about half of the deep ocean basin, that is more than 50%, and are the flattest region present in the earth. This is the picture of abyssal plain. In this you can see the irregular topography of the abyssal plain, and then the deposits deposited by the turbidite deposit located in the abyssal plain. Next, we will see about the abyssal hill. Abyssal hill is a hill located in the abyssal plain. It is a volcanic feature on the ocean floor that are less than 1000 meters tall, and the minimum height of the seamounts are called abyssal hill. It is also called sea knolls, and the abyssal hills are one of the most abundant features on the planet, and it covers a large percentage of the entire ocean basin floor. Abyssal hills are generally rounded in shape and they have an average height of 200 meters, and most abyssal hills are created by stretching of crust during the creation of new seafloor at the mid-oceanic ridges. Next one is the seamount. Seamounts are submerged volcanic mountains present in the deep ocean basin that are at least 1000 meters high. These seamounts rises above the ocean floor, form oceanic island, and the best example is Hawaiian group of island. Those that are below sea level but rises more than 1 kilometer above the deep ocean floors have a pointy top like an upside down ice cream cone are called seamounts. Worldwide, scientists estimate that there are at least 1,25,000 known seamounts are present, and many of which originated at the volcanic centers such as hotspots or mid-oceanic ridges. And next one is the Gayards. Gayards is a volcanic flat-topped mountain. It is also called table mount. If the seamount has a flat top, it is called a Gayards. Both of these features, seamounts and Gayards, are associated with the hotspots as these volcanic islands erode away and sink back at the ocean, they are called gyres. Gyres are flat-topped submerged sea mounds. It is also called table mounds. Next one is this is the picture of abyssal hill, sea mount and the table mount located in the deep ocean basin, that is the abyssal plain. Next we will see about the oceanic trenches. Oceanic trenches is an important destructive feature present in the deep ocean basin, that is the active continental margin. The oceanic trenches are deep linear scars in the ocean floor caused by the collision of two plates along the convergent plate margin. The landward side of the trench rises as a volcanic arc that may produce a group of islands or a volcanic mountain ranges along the margin of a continent. Best example is Andes Mountain. Andes Mountain is a continental or mountain formed due to the convergent plate movement. The deepest portion of the world's ocean are found in these oceanic trenches. In fact, the deepest point on Earth's surface, that is 11,022 meters, is found in the Challenger Deep area of Mariana Trenches, which is located in the Pacific Ocean. The majority of the ocean trenches are found along the margins of Pacific Ocean, and only few oceanic trenches are existed in Atlantic and Indian Oceans. This is the picture of oceanic trenches where two plates collide each other and the lighter plate subduct below the heavier plate and forms a trenches, and trench is the important destructive zone. Next we will see about the Pacific Ring of Fire. Pacific Ring of Fire is also called the Circum-Pacific Belt. It occurs along the margin of Pacific Ocean. It is home to the majority of Earth's active volcanoes and large earthquakes because of the prevalence of convergent plate boundaries along the Pacific Rim. In this region where more than two plates collide each other. So 70% of world's volcano and more than 90% of world's earthquakes are located in this Pacific Ring of Fire. A part of Pacific Ring of Fire is South America's western coast, which including the Andes Mountain and the associated Peru-Chile trenches. A convergent plate boundaries where deep ocean trenches are associated with the tall volcanic arcs. This is the picture of Pacific Ring of Fire which surrounds the Pacific Ocean, where more than 3 plates collide each other and forms earthquakes and volcanoes. Next we will see about the last portion of ocean floor, the mid-oceanic ridges. Mid-oceanic ridges is an active region where new oceanic floors are created. It's a continuous series of underwater mountain ranges that run along the floors of all oceans, and in a few places such as Iceland, this mid-oceanic ridges actually rises above the sea level. Mid-oceanic ridges form with the plates pulled away from each other. So mid-oceanic ridges is a feature of divergent plate boundary where two plates move apart from each other. Along the crest of ridges are reefs, which are narrow depression where the magma from the asthenosphere reaches the sea floor and forms the Earth's newest crustal rock. The mid-oceanic ridges results from the sea floor spreading along the divergent plate boundaries. The enormous mid-oceanic ridges forms a longest mountain chain which extending across some of 75,000 kilometers of the deep ocean basin. Topographically, the mid-oceanic ridge is a high feature and extending an average of 2.5 kilometers above the surrounding sea floor, and the mid-oceanic ridges cover 23% of Earth's surface. This mid-oceanic ridges is entirely volcanic in origin and is composed of basaltic lava, and it is the main characteristics of the oceanic crust. Along most of its crust, is a central downdraft rift valley created by the seafloor spreading where two plates diverge. This is the picture of mid-oceanic ridges where you can see how two plates move away from each other and how the mantle from the asthenosphere rises to the ocean floor. Next, we'll see about the features exist in the mid-oceanic ridges. First one is the hydrothermal vents. Hydro means water, thermo means heat. So hydrothermal vents are seafloor hot springs created when cold seawater seeps down along the cracks, fractures, fissures, veins in the ocean crust and approach an underground magma chamber. The water picks up the heat from the magma chamber and dissolved substance and then work its way back towards the surface through a complex plumbing system exciting through the seafloor. The temperature of the water that rushes out of a particular hydrothermal vent determines its appearance. Based on this, hydrothermal vent is divided into three. First one is the warm water, second one is the white smokers and third one is the black smokers. First one is the warm water. Warm water vents have water temperature below 30 degrees Celsius and it generally emits water that is clear in color. And second one is the white smoker hydrothermal vent. It is having a water temperature of 30 degree to 350 degrees Celsius and it emits water that is white because of the presence of various light colored compounds including barium sulfide which is barite. Black smokers have water temperatures above 350 degrees Celsius and emit water that is black in color. The color is due to the presence of dark colored metal sulfides including iron, nickel, copper and zinc. Many black smokers spew out of chimney-like structures. Chemical analysis of this chimney-like structure reveals that they are composed of various metallic sulfides and sometimes even important economic deposits such as silver, gold and platinum. So, this is the picture of hydrothermal vent where how the waters emit from the hydrothermal vent. Next, we will see about the fracture zone and the transform fault. Fracture zones and the transform faults is always associated with the mid-oceanic ridges. The mid-oceanic ridges is cut by number of transform faults, which means two plates slide past each other which offset or cut down the spreading zones. The oriented perpendicular to the spreading zone, transform fault give the mid-oceanic ridges a zigzag appearance. This transform fault occurs for two reasons. First reason is to accommodate the spreading of a linear system on a spherical earth, and the second reason is because different segments of mid-oceanic ridges spread apart at different rates. This is the two reasons for transform fault at the mid-oceanic ridges. On the Pacific Ocean seafloor, transform faults are prominently displayed. They extend for several thousands of kilometers away from the mid-oceanic ridges and have a width of up to about 200 kilometers. This extension, however, are not transform fault. Instead, they are called fracture zone. So, there was a difference between transform fault and fracture zone. So, this is the difference. In case of plate boundary, the transform fault has a plate boundary, that is transform plate boundary in these two plates slide past each other. But in the case of fracture zone, it's a intra-plate feature, that is no plate movements act on these zones. Second one is the relative movement across feature. The movement is opposite in direction like this, but in this fracture zone, the movement is in the same direction. If it is in north, the both plates, both sides moves in same direction. And third one is the earthquake. In the transform fault region, many earthquakes are happened, but in this fracture zone, only few earthquakes are going to happening or happened. The fourth one is the relationship to the mid-oceanic ridges. The Transform faults occur between the offset mid-oceanic ridge segment, but the fracture zone occur beyond the offset mid-oceanic ridge segments. And the example for transform fault is San Andreas fault, Alpine fault and the Dead Sea fault. But example for fracture zone is Mendocino fracture zone and Molokai fracture zone. This is the picture of transform fault fracture zone along a mid-oceanic ridges. Then last feature of the mid-oceanic ridges is oceanic islands. Islands are unusually tall features that reaches from the sea floor all the way above the sea level. There are three basic type of oceanic islands. First one is islands associated with volcanic activity along the mid-oceanic ridges. Best example is mid-Atlantic ridges. Second island is islands associated with hotspots. Best example is Hawaiian group of islands which is located in the Pacific Ocean. And third one is the islands that are island arcs and associated with the convergent plate boundaries. Best example is Japanese archipelago in the Pacific Ocean. Archipelago means group of islands. Note that all these three types of islands are volcanic in origin. Then finally, conclusion. The ocean basins varies in size, varies in shape and the topographic features. These differences tell much about the age and the evolution of each individual ocean basin. The purpose of understanding this issue is that there is a continuing crustal deformation due to the plate tectonics. Thank you for watching our video. Thank you.